Welcome back. I'm Mike Yawn, a Senior Solutions Architect with Hazelcast, and you're watching TelUvision. In this episode and the next, I want to talk about the high availability features of Hazelcast. I've split this topic into two episodes because these features naturally fall into two distinct categories. Today, we'll focus on the features that keep your Hazelcast cluster running smoothly during normal operations. This mainly involves upgrading software without downtime, whether it's Hazelcast itself, distributed computation code that runs in the cluster, or your business logic. In the following episode, we'll dive into the features that help Hazelcast stay available during different types of failures. This will be just a high-level overview of these capabilities. We'll do deep dives into specific features later. Let's start by looking at all the software-related changes you might need to handle. Let's start with rolling upgrades. In episodes 2 and 3, we discussed Hazelcast's elastic scaling. You can remove a node from the cluster, the data rebalances, and operations continue normally. When that node rejoins, the data rebalances again, restoring the original configuration. Rolling upgrades leverages this capability. You can remove a node, update the Hazelcast jar file to a newer version, and restart the node. Now, with the community version of Hazelcast, an updated node will not be allowed to rejoin the cluster because supporting mixed software versions is an Enterprise Edition feature. When you're in the midst of a rolling upgrade, the cluster operates as if all nodes are running the older version to avoid conflicts. Once all nodes have been upgraded to the new software version, the cluster switches to this new version, enabling new features. So rolling upgrades help when updating Hazelcast code. But what happens when it's your code that needs to be upgraded? The answer is it depends on what exactly is changing. I'm not going to go through the table here because we're going to cover each of these in detail on the following slides. User Code Namespaces is a new feature in the 5.4 version of the Enterprise platform. It replaces the older user code deployment feature from previous releases. Let's briefly touch on why this new feature is better. Both user code deployment and user code namespaces target code that you want executed on the cluster, such as entry processors, executors, and map stores. In embedded mode, this code is part of your application and so readily accessible to Hazelcast. In client-server mode, you need to make this code available to cluster members. Now, the simplest way to do this is to put the classes on the class path of all members, but that's not always going to be desirable. What user code deployment allowed was clients could push code to the Hazelcast members over the network, avoiding changes to the member class path. However, once this code was deployed, it could not be replaced without doing a rolling restart of the cluster to clear out the old code. This is a limitation due to the way Java class loaders behave. With the new user code namespace feature, we improve on this by allowing code to be replaced with a newer version without requiring a restart. The namespace feature also provides isolation, so multiple applications running on the same cluster can update code without interfering with each other. Another type of code that's needed on the cluster is for your domain objects. Now, if you're only storing and retrieving objects by key, the cluster doesn't need to know the structure of these objects. But for querying based on content or using distributed compute features, the cluster needs to understand the class layout or schema of your domain objects. Now, this is more complex than user code namespaces. With UCN, the cluster can forget previous versions once new code has been deployed. But if you've stored objects in a cluster and then change the class definition, issues will arise. Storing new objects with the new format is easy, but retrieving the old ones can cause problems, like an invalid class exception. Now, compact serialization in Hazelcast automatically tracks schema versions without requiring manual schema creation or version increments. It handles the storage and wire format of the data, but doesn't manage multiple Java classes for different schema versions. So the best approach to handling changing schemas or schema evolution is to pair compact serialization with the generic record capability. A generic record can represent any version of an object as its schema evolves. And we'll discuss this capability more in future episodes. Yet another way to deploy code to Hazelcast is by submitting jobs that run jet pipelines. Now, at first glance, this seems similar to using entry processors or executors, making user code namespaces appear suitable. However, replacing code with user code namespaces results in the loss of any state that is held within that running code. Now, this isn't usually a problem for entry processors, which run quickly and typically don't retain state between invocations. For a map store, a new connection to a database is typically all that's needed, and that's easy to regenerate. Jet pipelines, however, can be long-running and stateful. They may involve windowed aggregations and require checkpointing to provide at least once or exactly once processing guarantees. So replacing code for Jet involves more than just updating the class. It involves saving state, replacing code, restoring state, potentially rewinding and replaying data sources, and resuming processing without data loss. All of this is managed for you by the job upgrade feature, which is another enterprise platform feature of Hazelcast. And finally, let's talk about updating your application code. If your deployment model is client-server, updating your clients won't affect the cluster. But if you deploy in an embedded fashion, updating your application code means updating Hazelcast nodes as well. Now, rolling upgrades might work if your application can handle a mixture of older and newer versions running side by side. But if the upgrade involves breaking changes, you should consider blue-green deployments. With blue-green deployments, you set up a new cluster running the new software version. WAN replication can be used to coordinate or transfer data between the old and the new clusters, keeping them in sync during the transition. Blue-green deployments are also useful for making configuration changes that can't be applied dynamically, such as changing the partition count on a cluster or switching to a different serialization method. We covered quite a bit today. Let's summarize into some cluster facts. Rolling upgrades allow for seamless updates of Hazelcast software, maintaining cluster operation and enabling new features once all nodes are upgraded to the same version. User Code Namespaces in Hazelcast 5.4 makes it easier to update and manage code you deploy to your cluster, providing seamless updates and better isolation for multi-tenancy applications. For efficient querying and compute features, Hazelcast needs to understand your domain object schema. Compact serialization and generic record work together to provide a robust solution for managing evolving schemas. Deploying Jet pipeline code requires careful state management, which is handled by Hazelcast's job upgrade feature to ensure uninterrupted processing and data integrity. When updating application code, use blue-green deployments for breaking changes, and leverage WAN replication for a smooth transition and for handling necessary configuration changes. We'll be back soon with the continuation of our look at Hazelcast's high availability features. So tune in next time. Same bat time, same bat channel.